algebras. So welcome to your chapter 3 quiz review. So it's on lessons 1 through 4 in chapter 3. So chapter 3, lessons 1 through 4 review. Okay, that's what we're looking at here. And here, what we're going to do is we are going to just kind of do a quick summary of our functions. So I normally, for a review, don't make a video. But in this case, there's a few things that are kind of notesy that and some things that I want to go over just to ensure that you really are clear about this function stuff, because it takes us through really the rest of the year, and we've got to be very clear about these function things. Okay? So I'm going to go straight to page 2 to start. So I'm going to come back to this. I'm going to come back to page 1, but for now I want you to flip to page 2 to see this. Okay? Because this is the real thing that we're taking notes on during this time. So these are the functions that we're supposed to be able to identify by their equations, their graphs, their general shape. All right? We're going to start with a linear equation. Okay? And of course, you know that this is y equals mx plus b form. A general form is like y equals x. Okay? A slightly more complicated form would be something like f of x equals 1/2 x minus 10. Okay, so those are all different equations for a linear. They're graphs, of course. So here's a positive linear slope. Here's a negative linear slope. And here's a 0 linear slope function. Notice I didn't make a vertical line because vertical lines are not linear functions. They're lines, they're not linear functions. Shape is a line, straight line, which is redundant because all lines are straight. So there you go. Absolute value. I love absolute value because the A and the V. And that's the shape, right? V shape or A shape. Okay, V shape or an A shape. So I can actually go backwards here, right? The graphs are a V shape. So two lines that meet at a vertex like this, or an A shape. And I'll make this one a little more narrow, right? Two lines that meet at a vertex like this. Those are absolute value functions. So they do have slopes, but they're slopes going in kind of the opposite directions and meeting up at that vertex. Now, the equation of absolute value, the general form looks like this. So I'll give you the general form. Y equals A times the absolute value of x minus h in absolute value bars, and then plus k out here. Okay, so that's the general shape, and you're going to see that in lesson 6. It's the general shape of an absolute value graph. Okay, a very basic absolute value is y equals the absolute value of x. A more involved absolute value graph, let's do g this time. G of x equals a -2 absolute value of x plus 5. There's a more interesting looking absolute value graph. And we'll see a few of those and graph them in the next couple of lessons. Okay. Quadratics have a vertex just like absolute value does. We might know a quadratic as a parabola. Okay, so that's another thing you might know a quadratic function as. Quadratic functions are smiley face or frowny face. You could also think of them as U shape. So if you want to put U shape, right? That's another option. I like to say smiley face and frowny face because then you know which direction I'm talking about, right? Smiley face. And notice there's like a vertex down here. So there's a point that's a bottom and then we turn back around. And frowny face, right? And notice with this, there's a point that's like a top and then we turn back around. Okay, and those are the vertex points. And we're going to, when we discuss quadratics in more depth, we're actually going to find those vertex points, those maximums and minimums. General form, so we'll do standard first. Y equals ax squared plus bx plus c. So this is just general speaking. There's also a vertex form where it's a times x minus h in parentheses squared plus k at the end. And again, when we do quadratics in depth, you'll see that. So that's why I just wanted both there. Very general, y equals x squared. As long as there's x squared and that's the highest exponent, it's a parabola like this. Square root functions are, if we're keeping them functions, we turn a parabola on its side and we cut it in half because we need to keep it a function. So turn it on its side and cut it in half. It's like this. So a starting point like that, or like this. Okay, that's a square root function, one of those. So it's half a parabola on its side, right? Half a parabola on its side looks like this. We'll just do the general. Y equals the square root of x. You might see something like this. Let's do h of x equals the square root of x minus 2. How about I write the 2? There we go. That's the general square root, right? It's just half a parabola on its side. You turn that parabola over and you cut it in half. An exponential function, this is a rapid increase or decrease curve. So these are curves and they're an extremely quick up, or they're coming from up and they're an extremely quick and then even out down like this. And then they kind of like level out. And this leveling out is what we call an asymptote. Oops, that's an S. And if you remember from the type of function, I mentioned that an asymptote is an invisible barrier you cannot touch or cross. What's different about an exponential function is it's going to be something like y equals 2 to the x power, or y equals 1/2 to the x power. Those are both very general absolute value quadratic. Oh my God. Exponential functions. Those are very general exponential functions that you have there, right? So because of that, it's x in the exponent. When you've got that x in the exponent, that's what's going to cause this rapid increase or this rapid decrease. There we go. It's telling me to hurry along, I think. A cubic function is like y equals x cubed. Okay. A very like funky looking one, you can feel free to plug this into your graphing calculator after we learn that just to see, is something like f of x equals x cubed minus 2x squared plus x plus 1. Something like that. If the highest exponent present is a cube, a 3, then you've got a cubic function, and they kind of look like this. They snake up and kind of curve and then back up, okay? Sometimes not as pronounced, so it might just be like a little curve in and out like this. But notice it could be a really pronounced curve like that. Cubic functions. So I call them vertical snakes. Right? That's what I kind of call them because it looks like a little snake going up your graph. And it's vertical, it's up and down. And the reason I say vertical is because the cube root is like y equals the cube root of. So we call this the cube root when there's a 3 on the outside of your radical, x under here. These are horizontal snakes. So these come in real quick and then back like this. So that's why I call these horizontal snakes. Now, we really don't have a lot of detail about these two pieces in Algebra 1, but we have to be able to graph them using our graphing calculator. So that's the reason that we identify them during this time where we just have to know a type. We go into more depth on exponentials, quadratics, absolute value, and linear functions. So those types of functions we go into a lot of depth about. There's a little bit of square root, but not much. And so because of that, these really are, if you want to star them, these really are the main players in our year. Okay. Those four really are the main players in our year. You have to be able to identify the other three, though. So if I present you with one of the other three, you have to be able to say, oh, that's an exponential. Oh, that's a cubic. Oh, that's a cube root. All right. That's why I wanted to go over this. This part is kind of the only notesy part. The rest is all questions for you to answer. All right. And again, there's a lot of matching here, just like lesson 2's homework was. So a lot of matching. But before I do that, let's go back up front and just do one from each of these parts, just to make sure we're comfortable. So here we're explaining function or not a function. Answer it, and you can say NAF for not a function if you would prefer. I'm going to do number 2, and number 2 is not a function. And here's a vertical line that I draw that touches this graph in 3 spots. And if you have something being touched by a vertical line in 3 spots, it's not a function, or like I said, you can abbreviate that as NAF. Okay. And the reason this is not a function is you can say one of two things. It fails the vertical line test, or you could say X values were repeated. For something to be a function, X values cannot be used more than once. And a vertical line is literally an X value used into infinity. So if you can draw a vertical line on a graph and it touches that particular graph in more than one spot, well, you've had an X value repeat. So we can either call that a failure of the vertical line test, or we can call that X values were repeated. Either way, this is not a function. You can use that toward the other ones, right? I'm going to do number 5 down here. Okay. Number 5, it says A, state the domain, B, state the range, C is function or not a function. Okay. So the domain is left to right, the X values being used. So I'm using between -1 and +1. So that's the between inequality I make. -1 is less than or equal to X, which is less than or equal to 1. The range is the Y values being used down to up. So down 1, 2, 3, 4. So this is -4 down here, all the way up to 1, 2, 3, 4 up here. Okay. Those are the Y values that are allowed to be used, nothing outside of that. So I create -4 is less than or equal to Y, which is less than or equal to +4. Is this thing a function or not a function? This is not a function. And again, feel free to abbreviate NAF, but this is not a function because X values were repeated here. There's an X value used here and here that's exactly the same, right? And if that happens in even one spot, this is not a function. But I just wanted to remind you how to write those domains and ranges, right? And remind you what's a function, what's not a function. Let me also head back. So there you go. Let me also head back right here for evaluating. When you're evaluating a function, there we go. When you're evaluating a function, we're replacing X with this value right here. So what you do, this is the only thing I need to see written down substitution work-wise, okay? because you can do the rest on your graphing calculator, and I will in a second. So I'm replacing all my variables with -4. Now, I could do this in my head, or I can come to my graphing calculator. This is just telling me what I subbed in, which was -4. Okay. I can come to my graphing calculator over here. Just going to increase its size a little bit. Okay. So now what I'm going to do is I'm going to plug in 2 times -4 parentheses squared. I literally rewrite -3 times -4 in parentheses. So I'm rewriting that substitution and I get 44. So G of -4 equals 44. That's one way to write your answer. Another way you can write your answer is -4, 44. Because anytime you are using that input, you're getting an output. And that input is your X value, a point. That output is your Y value, part of the point. Okay? That's what you're doing. That's what you're finding. And so when you see it on a graph here, I want f of 4. Well, that's your X value of 4. So go down to the x-axis, 1, 2, 3, 4, and find where we touch the graph. And it's right here, okay, which looks like 4, 2 is the point. So what's the output? F of 4 equals 2, because that point was 4, 2. Okay, that's the output. It's the Y value or the output. All right. Then, of course, the rest is some matching stuff. All right. I want you to do all that stuff. And then we'll have our quiz in Delta Math for Chapter 3. All right. I'll be seeing you, Algebra crew. Good luck. Let me know if you need anything in class or office hours for you virtual peeps. And I'll be seeing you later. Bye, guys.